Okay, so here we have Lab 10, and Lab 10 is about designing shift registers with the D flip-flop that we can use from primitives library uh, in the Cordis Prime. So let me just go ahead and start a new project. Here for the first step, I'm gonna just design a shift register, which is basically just connecting 4 flip-flops together. So I'm gonna write here DFF, which would show me the D flip-flop like block here. And I'm gonna click OK. I'm gonna put ones here, right? So here, I mean, I don't know what is wrong with my screen resolution or whatever it is. So these pins are, this one is D, this one is Q, and this one is clock. And we have like PRN, and the other one is like CLRN. I mean, those two pins are these two here, which you can see with the circle. So the instruction is saying that we have to connect these two circles to VCC, which VCC means 1. And in order that flip-flop will work, but if you forget doing that, then I mean, you'll not be able to simulate anything, because these two pins will preset or will clear the output of the flip-flop. Like if you don't connect the VCC and stuff, so what the flip-flop would do is just like clear or set the output of the flip-flop every time, so you would basically see nothing. And just one more time, I mean, I need to explain VCC. So if you want to add VCC, just like go to the symbol, like icon here, and then search for VCC. I mean, you can find it on like under others here, and this is how it works. So the first step would be this one here, but the point I mean that we need to consider for the first step is if you don't, like if you connect the VCC, I mean all VCC to all the CLRN and PRN, which might stand for clear and preset, like pins of the flip-flop. So if you connect all of them to VCC and start simulation, so you wouldn't either set any initial value for, so you wouldn't set any initial value for flip-flops. So that will cause a problem, because if the flip-flop doesn't have any value, so whatever, like any initial value, so these 3 flip-flops wouldn't like change at all, right? I mean, maybe in this step you wouldn't quite see that, but because we have an input here, so even if like all the flip-flops they didn't have any sort of input, the first flip-flop, I mean the Q3 flip-flop, it's gonna have inputs, and if you just like assign any input to it after just few clocks, then the input would goes to this output and so on. So for the next step, we're not gonna have any sort of input to our flip-flops, so they should have kind of initial values. So so in that case, I'm gonna replace the VCC with an input, like and I'm gonna name this input as preset. And basically, what we will do is we are going to assign the preset this input 0, like for a few nanoseconds, and then we would immediately change that to 1, and we will keep that as 1 for the rest of the simulation. And the reason behind it is that when we just make the preset like this input to 0, it's going to set some values for these flip-flops. And that is sort of initialization for our circuit. And for the last two steps, you were supposed to show the output results in 7-segment display, which we don't have it right here. So I just came up with this idea that we can use, we did sort of grouping these output, and we show these output as 1, and we use this thick wiring like tool. And so what I'm gonna do, I'm gonna just like put this one here. I'm gonna change this name to Q, and I'm gonna write 3.0. And this means that this output has 4 different like values carrying along with it. And I'm gonna use this like wiring stuff, and I'm gonna connect these uh, wires together. And here we go. So, and then I have, I mean, as you remember, I have to rename these wires so that it can understand which wire has to belong to which element of this array. So, I mean, I think both of them would work if you just name it this way or this way, I think. So, I mean, I tried that one, so I will stick with that. So, Q1, this would be Q0, then here we go. So, and yeah, this is fine. Anyways, so I'm gonna assign a clock here for this one. For the input, I'm gonna assign, let's force it to 1. And then the preset, I mean, let's just assign it 0 and see what happens. And then I should see Q, right? I'm gonna run it for a sec here. For some seconds, so like 100 milliseconds. And there we go. Now, as you can see here, you can read a number like 0 here. So that is why I used this one instead. So if in any case you want to just like see numbers for even step 1 or 2, you can use this like kind of Q thing, like if you want. So now, because of this preset, I just force it to be 0. I'm seeing the all the shift, like the flip-flops there are they're all presets to 0. And like let's just keep the preset 0. And as you can guess, if the clock goes on, if the input is 1, we should get Q3 as 1, right? I mean, Q3 should change to 0, and what we should see in like as Q would be 8, right? So let's keep on and try, and if we can see any changes now. So if I change the preset to 1, it means that I have connected it to VCC. And then if I run it, now see, I got 8. And after the second clock, I mean, I would still fit the this flip-flop with 1. So this one would be here, and then the one would go would go to the next flip-flop. So what should I see? I should see 8 plus 4, which would be 12, right? So I'm going to write it one more time. I'm seeing C, which is 12, right? Now I'm going to stop the input. I'm going to force it to be 0. And so if I feed the first flip-flop with 0, then after this clock I would see 0, 1, 1, 0, right? This is how shift register works. So let's see. So 0, 1, 1, 0 would be 4 plus 2 would be 6, right? So okay, so it means that it has kind of delay, right? So I should have had changed the input to 0 in the previous cycle. So anyway, so I just had 3 ones, and then I had 0 as the input for the third flip-flop. And after this clock, this was like, before the clock was 1, 1, 0, 1, 0. And then after this clock, because the input was 0, then it changes to 0, 1, 1, 1, which is 7, right? So I hope that this makes sense. I mean, if anybody has any question, just mute his or herself. Anyway, so this is the basically what preset is doing here. And so, I mean, that is not a bad idea if I wanna. So for the simulation, to end the simulation, we can just do this instead of just restarting the program over and over. I just figured it out last week, so yes. And then make time step 2. Okay. So if you follow the same steps, so for the first step, you don't need any like preset input, and like you can always check that in like do file if you need preset or if you don't. And so for the first one, if you just follow the steps, this is what I did. And if you don't use this like multivariable output, then you would have this kind of figure. And so as you can see here, I didn't have any preset, and I just connected the those CLRN and PRN pins to VCC. So in the first kind of first cycle, for the second flip-flop and third flip-flop, maybe I can zoom it a little bit here. Where goes the zoom here? So as you can see here, for the first clock, the first Q3 flip-flop that didn't have any value, right? It was undefined. And the second one, like after 2 cycles, it just got some value, right? And so on. So that is why we use a preset input. I mean, as I have told already. So if we were like using FPGA and real circuit implementation, then we wouldn't need to do that, because every flip-flop, when you set it up, it's just gonna choose any sort of output, as like sometimes in random, but sometimes not. So it would have some initial values, but since we're doing simulation, so we need to just adjust those initial values ourselves.